I'm Anil Kumar, and we will further explore the graphs and their relation with higher order derivatives. Identify the graph of displacement, velocity, and acceleration, and then answer the following. When is object moving away? When is object slowing down? When is object speeding? You've already seen a couple of videos which are like this, so take a test on this. You can pause the video, answer the question, and then look into my suggestions. Now these graphs, on purpose, they are not of polynomials. And so answering this question is not that easy as it was in earlier questions. How do we find whether a graph represents displacement, velocity, or acceleration? This is a big question. So what we know here is that velocity is derivative of displacement. So we know how they are related. We know velocity is actually derivative of displacement, right? And acceleration is derivative of velocity. So that is how they are related. Now how do we find which graph is displacement, which is velocity? Basically, on any graph which we select, we have to find turning points. So the key issue here is to find turning points, right? Find turning points and relate them to the derivative f dash x will be 0 at turning point, right? So turning point of a function will give 0 on the derivative. So that is the key to relate these things, since all these three things are related with derivatives, right? So let's begin with this big graph. That is the turning point, right? So at this turning point, I have a horizontal tangent. Let's go and see where is the 0. Well, the 0 belongs to this particular graph. Okay, so we know for sure that derivative of this is this, correct? Now, let's look into this particular graph. Where is the turning point? It is increasing and starts decreasing at this point. So I can say that the turning point here is here. So at this point, we have a 0 there. That means this function is derivative of that. So in a way, we have the first cut at our graph, right? So we know that if the graphs are A, B, and C, then B is derivative of A and C is derivative of B. Now, so from turning points, we can always find how they are related. There are other parameters also. We could also see increasing and decreasing interval. Or where is graph increasing? Where is graph decreasing, right? So that could also help. So if the graph of f of x is increasing, then f dash x should be positive, right? Here, f dash x should be negative, right? So let's look into that part now. So as you can see here, it is increasing up to this place, right? And further up to here. So that means this graph is positive. That ensures that these two are related. So combining these two, we are kind of sure that one corresponds to the function, the other one is its derivative, right? Here, this is the turning point. The graph increases, right? It is increasing means positive slope. The other graph has a positive slope up to here. It is decreasing thereafter and negative slope thereafter. So we are 100% sure now which one corresponds to which graph, right? I hope this point is absolutely clear. It's very important, right? So the first graph here is our displacement graph. Its derivative at the turning point is 0, and so this graph represents the derivative v of t, derivative of displacement. And here, derivative at turning point is 0, so that graph represents acceleration. I hope that part is absolutely clear, right? Now let's look into the questions. When is object moving away? So part A, moving away, you can say displacement graph increasing. So we see s of t is increasing, right? That is one way. Other ways, v of t is positive. So clearly from both we get the answer, and the answer is from 0 to 5, right? So from 0 to 5, the object is moving away. So it is from 0 to 5, correct? Now, since I wrote t, let me change this to t. The independent variable, let me also write seconds. So then will be 0 to 5 seconds. Is it okay? Right. So now let's answer the second question, which is part B. When is object slowing down? You learned that slowing down means that velocity times acceleration is negative, right? This is key. Velocity times acceleration is negative. That gives us two conditions. The conditions are either velocity is positive, acceleration is negative, or velocity is negative, acceleration is positive. Their product will be negative. So let's investigate. When is velocity positive and acceleration negative? So velocity is positive from here till that place, and during this time acceleration is negative from this to this, right? So it is slowing down from 3 to 5. So that is one portion. So we have 3 to 5 for sure. Then let's look into when is velocity negative. Now velocity is negative thereafter, after 5. During this time, is acceleration positive? No, it is not. So this is the only time when it is slowing down, right? Now let's look into object speeding. Object is speeding when? When the product of velocity and acceleration is positive. So that means both are positive or both are negative, right? So let's look into the graph again and figure out when are both positive, when are both negative. So both are positive, acceleration is positive from here to there. So during this portion, both are positive. So they are speeding from 0 to 3. And both are negative after 5. Do you see that? And so they are speeding after 5. Do you see that? So that is how you can answer these questions. I hope the points are well taken. So go through this video once again, understand these concepts, and then move on and do some more practice questions. I'm Anil Kumar. You can subscribe and learn a lot from my videos. Thank you and all the best.